we are looking at the zero product property. And with the zero product property, you have to remember that you are factoring, because what the zero product property says is that if two things are multiplied, so take m and n, and they equal 0, that means that either m is equal to 0 or that n is equal to 0. One of these two things has to be equal to 0 in order for the multiplication, the product of these two things, to equal 0. So when you're looking at quadratic equations, remember we have ax squared plus bx plus c, and we set it equal to 0. We want to factor this so that we get two factors equal to 0. Once we do that, then we can apply the zero product property, saying that this first factor is 0 or the second factor is equal to 0. And these two things right here, once we solve them, that will give us our zeros. Now, saying that, zeros, those are the same thing as x-intercepts, where we're looking at a graph or an equation like a function or anything. They're also sometimes called roots. So these three terms are actually all meaning the exact same thing. When we talk about zeros, x-intercepts, roots, we're really meaning the exact same type of thing, okay? Now, let's look at an actual example of how we would solve a problem. So if we want to solve when we have 6x squared plus 11x is equal to 10. Well, the very first thing, and I need to have a 10 there instead of a 0. The very first thing I want to do is I want to get this equation equal to 0. So I want to move that 10 to the other side of the equal sign. And in order to do that, I need to subtract it because it takes a toll. I have to pay a toll in order to move across the equal sign. And so now I have 6x squared plus 11x minus 10 is equal to 0. Now I need to factor this thing. There are multiple ways of factoring. There's AC method, there's the trial and error method, there's modified AC method. I'm going to do what's called the modified AC method, in which I need to know what my A, my B, and my C is equal to. My A is equal to 6, my B is equal to 11, and my C is equal to a negative 10. I'm going to take my A times my C. So 6 times negative 10, which will give me a negative 60. I'm going to draw this X. And then I'm going to put my B down here, positive 11. I need two numbers that will multiply to give me a negative 60, but that will add to give me a positive 11. So these two numbers have to multiply to give me a negative 60, but they need to add to give me a positive 11. So whenever I'm looking at this, I can think of different numbers. So since I need to multiply to get me a negative, one's going to have to be positive and one's going to have to be negative. And I want my larger number to be positive because my addition is going to be positive. And so I can do a 60 and a 1, a 30 and a 2, 20 and 3. Notice that these two things added together, positive 60, negative 1, that would give me a 59. 30 and a negative 2, that gives me 28. 20 and negative 3, that gives me 17. 4 and 15. Oh, right there. 15 and negative 4. That's what I would consider my magic numbers. There's only going to be one set of them. So they are going to go here. Now, my A is always going to go here on this denominator. I always have to divide these numbers by that A. And I'm going to simplify if I can. 15 and 6. Yes, I can get 3 out of both of those. So that would be a 5 and a 2. And this, I can divide both of those by 2. So that's a negative 2 and a 3. When I put them over here, my denominator is going to go in front of the x. And remember that this is positive, so I get a 2x plus 5. Here, my denominator goes in front of my x, so 3x minus 2 equals 0. And you can always check yourself by multiplying these back together. But in this case, I am now going to set each factor, 2x plus 5 equal to 0, and 3x minus 2 equal to 0. So I subtract my 5. I get 2x is equal to a negative 5. I divide by 2. So x is equal to a negative 5 halves, or add 2. So I get 3x is equal to 2, divide by 3. X is equal to a positive 2/3. With math, with algebra, you can check yourself. So check, plug in those values. Negative 5 halves, 6 times a negative 5 halves squared, plus 11 times a negative 5 halves, does that equal a positive 10? Then check your other one. 6 times a 2/3 squared, plus 11 times 2/3, does that equal a positive 10? And yes, both of those should check out. So your solution set would be a negative 5 halves and 2/3 would be your solution set.